exam week, there will be no classes. Okay, I know you are waiting from me for information about the final demo. I got a good amount of responses from the project groups. So tentatively it looks like it will be Thursday. I will be in communication with you over the next 2 days to finalize the time. I know a couple of the groups mentioned more like afternoon. So I have all your information. Those you haven't sent me, if you get a chance, please do. And then please let me know if for any reason any group cannot make it during that time or anything like that. But from your responses, and I would say I have more than half of the responses group-wise, it looks like a Thursday afternoon. Okay? And I will be in touch over the email. So not leaving you hanging. You will have a quiz. So the 20, call it a quiz or an addendum to the final. So 20 points on the design patterns and your final project demo. That is what will be expected from you, right? Like material-wise, today we are looking at the last two design patterns. So I would like to look at the decorator design pattern from the structural category, and we will be looking at the state design pattern from the behavioral category. As I mentioned, you are highly encouraged to include a design pattern, the use of a design pattern in your project, but you are not required to. From my experience, again, the state diagram, which used to be a UML behavior diagram, and which is kind of a soft requirement in the sense that I don't say make a state diagram, but I say that make sure you include a behavioral UML diagram as part of your documentation. If you find that state diagram to be second nature to you, it was very simple, you could see how it was made, then the state design pattern would also be something you could look into. Again, for those of us who did not find the state diagram easy to make, I would, on the other hand, also encourage you to not use it. Okay, so it's not the easiest, but if that was second nature to you, then probably state diagram, state design pattern also becomes very second nature to you, kind of. Just telling you the correlation. Okay, so let's look at the decorator. Before we do, briefly remind me what to you is the adapter design pattern now? When do we use the adapter design pattern?
We have
incompatible client and client usage and the interface of the module the client is trying to use. We create a new module, and what it kind of does is it conforms to the interface that the client wants, right? And then like forwards the call and makes the appropriate calls in the thing. So you don't have to change either code, but you add a new piece of code that is like the middleman, right? So it says, okay, you give it to me, I'll make sure it is delivered. And I'll receive it for you and bring it to you, kind of, right? That's an adapter. How about bridge? When do we use bridge? Or what is bridge good for? With bridge, the term that should come to mind is decoupling. Okay? We are trying to decouple. What are we trying to decouple is the interface and the implementation. Okay, while we saw the first level of decoupling long time before when we talked about the object-oriented theory, and the very fact that we can put the code as the header file and the CPP file is a kind of separation that the client only needs to look at the header file and not the implementation. This is going deeper into that kind of decoupling. Here we are kind of decoupling the interface from the implementation completely so that each can evolve on its own. It is not dependent on each other. And how do we implement it? Basically, we have now, instead of being the header and CPP of the same file, these are the base classes for two hierarchies, and we use one of the implementer object as a data member in the interface, right? So it is a combination of the composition strategy and the hierarchy. Okay. Now every time you see hierarchy, that's another thing to mention when we are talking about design patterns. A lot of them have been designed, okay, so that if a hierarchy is needed, it can be created. It's not a required part of the design pattern. You might have a situation where you don't need a hierarchy, all you need is two classes, okay? But in many of these design patterns, you see there is a base class that has pure virtual, and then you have the concrete. Why is that a good way to do? Because then in the future, if anybody needs to extend, right, what does the hierarchy allow you? It allows you to extend. You don't have to change things. You just keep on implementing. But you, as the starting point of the design pattern, if you are starting the use of the design pattern, right, chances are you probably don't need a hierarchy. So it's not a requirement. Okay, you might just create that base class, and that's enough for your project. You may not need that. Okay, but in the solution, you will typically find a base class and the inherited class, so that, again, from the idea that this can be extensible. Okay, so keep that also in mind. Don't get lost in saying, oh, it's hierarchy, so it has to be complicated. No.
Professor,
Yes.
before starting, can we get what exactly you are looking for in the documentation part?
For the project? How about I finish design patterns and then I'll open up the floor. I'll stay as long as you need me to. I'll answer all your questions, okay? So I'm in no hurry to leave, so I will make sure that all questions are answered. Any part on part 3 or 4 you want me to go over, anything, okay? So hold your question, don't forget it. And then the last thing we saw last time was the facade, and that was a simple concept, right? Instead of having to call 3 different places, you are providing a service. Again, it's like kind of a middleman. But here, the middleman is not trying to, make the incompatible interface and calls compatible, but is trying to provide a better user experience. So saying, instead of you having to making those 5 calls, make that call to one place and they will take care of putting it all together and getting it to you. Okay? So the implementation wise, you will see a similarity that they are both forwarding calls, kind of, right? In the adapter, it is taking the call in a certain format and passing that same information in a different format. That's what is happening. But in the facade, what we are doing is, we are taking the call and then chunking it apart and sending it to the right thing. So here the call comes and gets divided into different parts. Like the example we saw was a loan application, where earlier you were interfacing with the bank, with the credit, and I forgot the third one. But the idea of the facade was now just interact with the facade. It will take care of contacting the bank and the loan and the credit bureau, everything for you. Right? It's like a facility. It's about, so many years back we had started the process of looking for a house. I mean, believe me, it was one of the most educational experiences we had, having no idea, coming from how the credit rating works, etc., all the details. It was a very interesting process and continues to be. So you could, one thing we learned at that time was, you could go through a realtor where, because there's a lawyer involved, there is the loan approval involved, and a lot of other things, Or people who have done this all their lives say, I'm not going to, of course the realtor is making a commission. I'm going to save some money and I will talk to these people directly, right? So the fact if you are using a realtor is like using a facade. So you just are talking to the realtor and then the realtor is arranging all these people. At the closing you need a lawyer and before the closing you need a house inspector, all those kind of things. Otherwise, do you need a realtor? No, but then you are making all those phone calls, right? So facade is, and it's true about a lot of service industries. I mean, booking your tickets, are you going to go to the airline directly or are you going through a ticket agent? Is the same thing as a facade. So you see a lot of examples of facade in your day-to-day life. So it's a very easy concept to grasp. Now today we talk about the decorator. So again, as the term suggests, decorator is basically adding embellishment to a object. Okay. Right, so it's saying attach additional responsibilities to an object dynamically. Decorators provide a flexible alternative to subclassing for extending functionality. So here for the first time you will see an alternative to extensibility as to how. You know, it's a very simple example. You open your word processor, you start typing your paper, right? Kind of options. What font would you like? What size would you like? Right? They are the same things, but there are so many options. Right? So similar kind of things here. One might decide, I mean, just before this in the previous class we had 4 presentations, right? Every group had their own way of presenting, right? Some of us feel that the content is most important. So as long, I don't care about all the decorations and the graphics and every other fancy stuff. It is just that the information is the most important and that is where we focus, we put our energy in. Some people say, okay, you know, that is, but a part of a good presentation is also making it, you know, fun to look at, you know. So, is one correct? Is one more correct than the other? No, they have their own strengths, etc. So, same idea here. Let's look at the decorator pattern with all that in mind. So again, in the same way that it was, we looked at the others, when do we use the decorator pattern? So you think of the decorator pattern when you need to add responsibilities to individual objects dynamically and transparently, that is without affecting other objects. So what you are doing is, you are picking up, I don't know, I'm trying to think of an example. You know, let's say we pick up a student, right? So now that student is possibly already pursuing a particular degree program. Now you say, oh, this is a good candidate to serve on the student congress, right? He or she is also a good candidate to, I don't know, to be on the athletic team, one of the, you know, the swimming team. Or something. So depending on what all other things are because all these additional additions to the portfolio is increasing your responsibilities. What meetings you will have to attend now, right? What kind of requirements you have to meet now. You are extending those. Typically we talk about adding responsibilities, but on the same note they can be withdrawn also. Okay, so it's the flexibility. Okay, you know, a particular athlete got injured. Okay, we have to have enough for this semester, we'll take off that status so that, you know, those requirements can be waived off, kind of. So you can not only add but withdraw. When extension by subclassing is impractical, sometimes a large number of independent extensions are possible and would produce an explosion of subclasses to support every combination. Or a class definition may be hidden or otherwise unavailable for subclassing. And in some way, this third bullet point reminds me of the initial issues we had with the dice phase hierarchy. And I was having this conversation with one of the groups on Monday itself. I said the problem with the dice space hierarchy was that we were using all the attributes that the dice space had to make it into a 3-level hierarchy. Whereas typically you have a set of 10 attributes and you pick up 2 of them to make that the basis of the hierarchy. So it seemed like an overkill, right? And also on that note, it could have come to mind that, okay, if I add another level of information on the dice space, like a number on the dice space, am I going to create so many more classes, right? And would that become like, does it make sense to have at the end, if we had right now 8 classes, to have, and let's say a number 1 to 6, a kind of 2 and then 3 and then 6, right? No, 2, 4, 6. So 2 into 4 into 6 which becomes 48 classes. Is that a practical way to go? Okay? So if those kind of thoughts came to your mind, they were, it made sense, right? And that's what we are kind of bringing up here. Again, where has it been used? It is used a lot in your widgets. Again, one of the most common things, or you might be taking it up after this class if you are interested, is Windows programming. How do we decide what kind? Should the window have a maximize, minimize button? Should the window have a 3D border? All those kind of things. Do you want it to be there? Do you not want it to be there? It's flexible. It depends on the designer. It may be, some part of it may be related to functionality. Some part of it may be just the way it looks. Just the aesthetics of it. So you can add on those or take off those as you require. So it's very flexible. It's on the go. Okay? So let's see how it happens. So here is your structure and class diagram. So on top of there is the component, okay, and then you have the concrete component. So you will see, so this is a little bit more involved as far as the implementation is concerned. It is kind of together, so to say. So the component has a decorator. So you see there is like a loop if you see there. So a component can have one or more. That diamond on the side of the decorator is the one-to-many relationship. So one component can have one or more decorators. Okay, and then the decorator itself. So you see the use of hierarchy, but it is much less. Decorator has your concrete decorator A and concrete decorator B. So there are these 2 independent hierarchies, but the important part here is the connection between the component and the decorator. So the decorator pattern is implemented by defining an interface for the class that needs decoration. So in our example, if we are talking about a window, then the window that will have its added functionality. So that's your component, the component class. Okay, so that's the interface for the class that needs decoration. And the decorator inherits from this interface as well as contains an object of it. That's the technical part. That's the real thing that is a little bit more involved here. So so what did we do with that? So first of all, see them in isolation. There is the component and there are the decorations, okay, on top of that component. So the component can specialize its own way, the decorators can specialize their own way, okay. Now how are they connected? They are connected such that the decorator is inheriting from the component, even though decorator is not a kind of component. Okay, so this is how this is. So it is a child, but also it contains an object. So it contains a base class object into it. Okay, so here you don't see an is a relationship at all. Okay, so decorator is not a component. Okay, so that's what it is saying is the diamond was your aggregation, that it contains that. It's a one-to-many relationship there. A decorator can add extra behavior, another method or state to the inherited interface, and you can see that in the slide. So I think, let's see an example. So it's just showing you something. So here is your text view with decorators. You can have a border decorator, you can have a scroll bar. So see, this is the thing that you look at, and that part of the diagram shows you these things separated. So look at this as a window with a scroll bar, right? A window with a border and a window with the text. They are put together, but they are really three. I don't know, have you ever worked with Photoshop? It typically goes in layers, right? How you can divide the image into layers and then change it or then put it all together. Think of that kind of concept here. Okay, so that's what is you are looking at.
So what will be iterative, Professor? In the diagram, other diagram you are showing there is an iterator. No, the class. Yeah.
Here, no, it's not an iterator. What it is showing you is, see, there is that, so that is there the window, the component. The window will be the component class, right? And then there is your decorator. So what is the decorator? The decorator is inheriting from the component, so it's a child class. So why is it made child? So that it can get its functionality.
So window is the parent and decorator has three.
It is, yeah, it is so it is an inheritance without the usual purpose of inheritance. The most common purpose of inheritance is to specialize, right? As is a relationship. But here that is not the case. Okay? So this is a different use of hierarchy. Okay? So here, why are we using hierarchy? To get that code, to reuse that code. So not only are we inheriting, but we are also maintaining. If you see the first rectangle under the decorator, it says it has a data member of type component. Okay? So it's inheriting, and it's also saving an object of its base class as a data member. Okay, so consider this the element of implementation of the decorator. Okay, let's look at the example, and as I said, this is probably the most whatever we have learned, it's tough to fall back on right now as far as inheritance is concerned. Okay? It's a little bit of an unconventional use, if I might use the term. So here, see. So what's happening here? You have a e-border decorator, a scroll decorator, and a text view. Right? So you have these are your three windows that we were looking at. One had the border, one had the scroll view, and one had the text view. So we divided that into those three layers. And that is what you are looking at as three different objects. Okay? Now, they are each a different decorator. Right? What will be common? What do you see is common to all of them? The component. Okay, so the window here is termed as the eye visual component. So the eye visual component is the window. So what is common to them? They have the same object as the data member. Okay? As I said, it's a little unconventional. Typically we think about the window and then we add on the attributes we want to by specializing it, right? Here what is happening? We have this window, we want to add these attributes, but how are we adding it? We have three different attribute related classes that are inheriting from this and also have this as an object in their class. So what is common to, so these three are not related otherwise, they are more of like siblings, that they are three decorators. but they are holding the same object into them. So when they do something to the object, all three of them are doing it to the same object. Okay, it is, as I said, this is not something we've seen before. It's a little different, and therefore you will probably you'll have a little bit higher learning curve here. But this is a different way of adding attribute to the class. The object here is same. So the eye visual component here is like your is the window basically. Here is that diagram with the thing, right? So you have your eye visual component, you have your text view, you have your decorator. The decorator is either a scroll decorator or a border decorator. So what they've done is, text view is the basic window which can contain text. That is it. So what they did was, they said a window can contain text. Everything else is a decoration on it. Okay, so the border is the decoration, the scroll bar is the decoration. So going back to our class diagram, our base is the basic window, and then it specializes into the text view. That is normal inheritance. Okay, a window that can contain text. But this other side, the decorator hierarchy, is what will get added to this window. So the decorator is two kinds, scroll decorator and border decorator, and it maintains an object of component class. So that whenever they use that object, whatever border decorator does and whatever scroll decorator does, it is doing it to the same object. So if the scroll decorator will say, oh, I want to add the scroll. Who is it adding to the window? The border decorator says, I want to add a border. Who will it add to? The window, to the same object. Okay? So the drawing of the border or the scroll has been brought down to these decorators. Okay? Whether one is called or not will depend on how your window will look like. So on the fly you can decide whether you want the scroll or the border or the whatever else or not, or if it is there, you may say don't show it. If you go into Windows programming, again, Windows programming, although there is no real similarity in the sense what you would be doing, but will feel like STL in the sense that a lot of code is out there. It's more about learning to use those libraries rather than writing a lot of code from scratch. Those libraries have immense potential what you can do. And what C# has done, so C# when it was put together had 3 languages in its mind when it was developed, right? So it kept the syntax structure of Java, right? It used the efficiency kind of C++, and it used the interface of VB. Because VB has the GUI interface, you add properties and so on and so forth. So what you write, what you would be doing is just putting check marks whether you want scroll bar or not, etc., etc. But the code that gets generated behind it is similar to this. When we used to do Windows programming in C++, it was a lot, you had to know a lot more about these things because you didn't have the VB kind of interface. But know that what is being generated behind is this kind of a structure. You wouldn't be writing code like that. You would be just checking off checkboxes most of the time to design your GUI. But it helps, whether you have to write it or not, it helps to know what is behind the scene. It's good. The convenience of using the GUI is for you and me, by which I mean is for the programmer and is to support faster development. But in that faster development, we don't want to completely not know what is happening in the back end, right? It is like the keyless cars today, right? If it doesn't open now, what to do? First there was a mechanical way of doing something. What do you do now, kind of? So don't forget, we still need the know-how. Another class we do that I teach is ethical issues in computing, and last time I offered it, we did the paper on driverless cars. self-driving car. And very, very interesting. In one of the papers, the student's objection to it was that the society will lose the art of driving. That is how yes, we are touching the human life. So you might say, oh, it's much better, less accidents, will not be tired, so on and so forth. But at the same time, one great day, if this had been, who will drive us from one place to the other? Do we still know how to drive or not? Something, a vague similarity, so to say here. I don't want you to have to do this kind of coding, but I want you to understand this kind of coding. Okay, and then basically, so what you see in the ensuing slides is the implementation for this. So you have your iVisual component, which is the abstract class because of the presence of the pure virtual method. You have the text view, which we said, so you see uses your public inheritance, right? So it's a specialization of the iVisual component and has your draw method, just like a stub of a method. It just has a cout statement saying that this is from where. And then you have that decorator class, and again is inheriting from the iVisual component, again pointing out that it holds a pointer to the base class object, right, there, and here is, basically initializing that pointer. The other two decorator classes, the border decorator and the scroll decorator, inherit from the decorator class. So even though they don't do it here, they do get that component. You are seeing the explicit calls to the base class decorator component, so it's passing it there, and then it is passing to its iVisual base class, and that is where it actually gets initialized. And here you see, so this calls the draw border. So it's the job of the border decorator to draw the border. Okay? Same idea for the scroll decorator. And let's look at the test code. So what are we doing here? Remember, iVisual component was the abstract class. So where did we have the concrete class was the text view. So we created a text view pointer and created a text view object. Okay, so here we are not worrying about, so you are not using a base class pointer to create any of the child classes. You are simply creating a base class object, the text view object here, just calling it their hello world. But what we can do now is we are creating a border decorator pointer, creating a border decorator object, right? Now remember, the border decorator object as part of its data member will have what? A component object, right? Which happens to be the base class of text view. So we can pass the text view pointer to initialize that method, and through that now we add the decorator, the border. And same idea with the scroll decorator, we passing the border decorator object in that case, and we can add the scroll. So what we are, instead of forwarding the function calls, what is getting forwarded here is the pointers, or in a way the objects. So the text view is created, it gives itself to the border decorator, and what does the border decorator do? Adds the border to it, and then gives, this object is given to the scroll decorator, and then it adds to the object. So now this is client code. It's totally up to the client to decide whether it wants to add a border or not. Think of it, let's say there were a couple of more decorators. There was the border decorator, scroll decorator, there was maximize, minimize, and what else? A resize, right? So are you going to pass these two through all four? through 3, through 2, through none, client decides. Because why? Because all of them have the same base class. So they are not related to each other, but they have something in common. Now you see why that iVisual component needed to be the base class. Right? So it is like kind of, in my mind at least, it helps me to think of it as object forwarding. You forward it to, it's like each of us specialize in something, right? And we are creating an object and we decide, one of us is very good at painting, another one is good at making a border. Let's say we are making greeting cards, the first thing that comes to mind, for example. So maybe I start with the card and then we decide what all we are going to do on this card, and based on that, we pass that card along and you add your special touch to it. If that was part of the original plan. That is the idea of the decorator design pattern. Yes, Kaushal.
So if we want to skip maybe the border decorator.
Yeah, you can. So I could totally scrap out the second line, and instead of passing 3BD, I could pass 3TB.
So it will take.
It will take, because all of them have the same base class component.
Or do we need to have the LHS part as the base class pointer?
You have what? Say that again.
Instead of text field, do we need to have the base class pointer?
No, it's,
The left side.
so instead of you are saying text view pointer,
Yeah, the whatever is the base class.
again, text view object is a iVisual component object by inheritance, right? A derived class object is a kind of base class object. So wherever I can pass a base class object, I can pass a derived class object. So that's why you can pass it. Okay, and that's why it needs that common base class for the whole thing. So decorator, so the important point to understand here is decorator and the window is not connected, so to say, right? That you say they are part of the same family. But why are they connected in this case through a common base class? Because you want to pass this, we need a common object to pass, that everybody can accept this, if we are playing passing the parcel, that everybody can accept this parcel. That's the reason of this common base class. So you see a use of inheritance that has been a little unconventional as far as to what we have seen thus far. Okay? Yes.
So can I change the order as well? Can I call the text view in the last?
Yes, I can. No, I can call text view in the last. Text view is the one that is the decoration is added to. Right?
So there should be.
So if you say, can I create a decorator and pass that decorator to text view? Technically, yes, but it makes no sense. That's only thing. Can you? Yes, you can. They share the same common base class. But that is not the intent, because text view is the starting point and now I am adding decorations. But for some reason, if scroll window was the starting point and then you added text as a decoration, then you could do it. In this example, text is the starting basic window and then we are adding scroll bar and border. But if for whatever reason, let's say border was the starting point, and then you added text and then you added this thing. I mean, think of the blank document and you add a text box. It's just how you think of it. So is it possible? Yes, it is possible. Okay. So see, everything has been added and then it draws. So it will draw all these three things. Basically here given by the three output statements. This is not a GUI program. Okay, so I think we talked enough of the elements. You have that component which is your base class, and then the concrete component which is a real specialization, and then all the decorator hierarchy that is put under the umbrella of the component. that brings us to the last one, which are the behavioral design patterns. Again, the general idea here, we had seen first creational, what we want to be done at time of object creation. The second set talked about the structure of it, and now we look at the behavior. So here we are looking at the algorithms and the assignments of responsibilities between objects. We described not only patterns of objects or classes, which we did in structure, but also the patterns of communication between them, because that is the part of the behavior. So again, in class scope, we use a lot of inheritance, and in behavioral, in object scope, we end up using a lot object composition instead of inheritance. So that's our last design pattern, the state design pattern. Why to use, or what is a state design pattern? It allows an object to alter its behavior when its internal state changes. The object will appear to change its class. So, yeah, I see that expression on Amson's face, and you're saying, okay, now what happened to my object-oriented programming? Now objects are becoming magical, right? They are changing classes, and therefore read it as it appears to change class. Okay, it doesn't really change class. Okay, so it will feel like a magical Disney kingdom, but not in reality. Okay. The following slides show a comparison between a traditional case statement and state pattern. I like this, I think again, talking to one of the groups last time, we went a little bit into detail, saying, why do I have to use so many if-else statements even when I'm using this, and we just walked through the scenario as to how you would have even more if-else statements, and that kind of makes the point here. So typically, how would you have, so think of it this way, there is an object, right? And there are 4 methods. I'll take a very simple example of, let's say, an interactive user menu, right? You say, if you want to display the contents, one of the programs I think we did one time was a library catalog, right? So we basically had an interactive menu saying, 1, if you want to see what books are available that you can borrow. 2, you can do something else like borrow a book. 3, you can return a book. 4, you can do something else. So based on this, right? So when you implement this kind of logic, you say, okay, what did the user enter? Everything is connected to a function call. And based on what was entered, you make the appropriate function call, right? And that's what it is doing, is it's saying switch state. So state has that user option 1, 2, 3, 4. If it is state 1, do method 1, right? So display the contents of the catalog. If it is 2, then call the method that runs you through borrowing part. It will take the request, take it off the available titles because you have borrowed it, etc. And in your name put it kind of. 3, if you are returning, it puts it back in the available titles, right? And so on and so forth, and maybe 4 to quit. So you call different methods based on the user input. That's what a classic case statement will do. Now a state pattern object, right? So to think of it, what it is saying is that something can be in state 1, which is the dot there indicates the start state, right? When an action brings it to state 2, again, those of you who are coming with the engineering background, this is typically the state diagrams you make for your machines, right? You use it more heavily than we do here. Then another action brings it to state 3. It is possible that I might need to go back to state 1 if that action happens. In our example, what was that action? Was the user input, right? Whether the user chose 1, 2, 3 or 4. And the system was going in a different state. It was going in a take the return of the book state, or going in help the user borrow state, kind of, right? So that is what is happening here. So again, how did we do it earlier? Was the traditional solution was to use the switch case statement, and now we'll see a more sophisticated way to deal with this. So your switch case statement, modify the switch structure if new states are introduced. State pattern, new concrete state classes derived from an abstract state class, while we need new states of context. We don't have to change or recompile the context's code. So when do I use this state pattern? We use the state pattern in either of the following cases: when the behavior depends on its state and it must change its behavior at runtime depending on that state. Operations have large multi-part conditional statements that depend on the object state. This state is usually represented by one or more enumerated constants. So either there is already implementation using the switch statements, and you've seen that these are very big multi-part conditional logic in that. So that is somewhere state diagram should come in. Or right when you are starting to create a new application, if you see there are different behaviors that are exhibited at different times, then that is another place you could use that, the state diagram. Again, heavily used in your socket programming, and when you are looking at your networking and TCP connection protocols, they are in states, because you have my knowledge of these are a little rusted, but if I remember correctly, TCP was like a 7-level protocol, right? No? 5 level? Okay. I give it, I'll listen to you answer 5. As I said, my knowledge is a little rusted, so 5-level protocol. So you could be at one level at a given time, and which level you are is based on what the event that happens, right? So, again, used a lot there. And I cannot question you right now, finals are around the corner, so I'm sure your knowledge is very much polished at this point in time. So here is what the class diagram looks like. So you have one part is the hierarchy of states, as many states as you need, and then what happens to the state? The context, right? A state has many contexts there. So it holds an object of type state, and then this state, see what it is, it's the base class pointer. So that base class pointer can point to any child class object. Remember the term, it appears to change state? Because this base class pointer will point to different state at different points in time and call the same method handle. Inheritance and polymorphism at work. Okay? So it appears it has a lot of states. What is your current state is what the base class pointer will be pointing to, and at every time all it does, it calls, now instead of the case statement choosing between different methods, what have we brought it to? That we have kind of, if I might use the term, at least not really implementation wise, but conceptually, wrapped those methods in the same method name, right? I'm just calling it handle, right? And overridden. So is all those different methods, but they are in these different states. And now this state classes is what I am pointing to. So in that state diagram, whatever was my starting state is what the constructor will make the base class pointer point to. Event happens, user input 1. I don't call the method, I switch the state and call the handle. Switch the state, call the handle. Switch the state, call the handle. Okay? So that is how it has been done here. Why do it this way? Because somebody thought of it one lazy afternoon that this is another way to handle it.
So that the person who's calling the state class just has to know to call the state class and not worry about the polymorphism or whatever the
That's one thing that probably you don't need to, you weren't going to worry it even if you were writing your if else statements.
But then we have to tell the machine, right?
Dynamically.
I haven't heard the really good answer yet. What you are saying is not wrong. But what's the good answer? What does inheritance bring with it? What's a very desirable feature of inheritance? Extensibility. Tomorrow I have new states. We don't have to add that if else clause. Okay. Remember, the biggest strength of object-oriented programming, I mean in a field which is relatively young and where the programming paradigm has shifted every 10 years, for object-oriented programming to be there in its more than third decade of existence, it had to offer something really good, right? 80s, I don't even count 80s. 80s it was developed, we started using it. But a solid 90s, a solid 2000s, and now close to the, at least better half of the 11s to the teens, right? There has to be something really, really solid. And that's what brings the flexibility, the extensibility. Here now you are seeing the real power of object-oriented programming. Okay? So that's why. So let's look at how it is done. So here concrete state classes are usually implemented in a singleton pattern. So you see here a design pattern making use of another design pattern. Why? Because every state should only be one. There should not be multiple objects of that state. There should be only one object of that state. So therefore we using a singleton within the state design pattern. So here is your example on the TCP. So here is your basic state diagram. When you start, you have a closed TCP closed. When you get an open request, the TCP goes to the listen mode. Another open request goes to the established. If it is closed, then the connection goes in the listen mode. If another close, it closes the thing, right? So you go from the closed state to the listen state. If then established, come back to listen mode, and then maybe totally closed, or might instead of being closed, you could be opening, establishing again, right? So basically staying in that listen mode as long as you are needed. So the start and the stop state here is the same in this diagram. So here is the corresponding class diagram. You have the TCP connection and the TCP states. How many states did we see? 3 of them. Connection closed, connection established, and in the listen mode. They all have this open, close, and acknowledge methods which were added there. And then the TCP connection class has a pointer to the TCP state. Now what it points to is one of them at a given time. Okay? And then it uses that state class to call that open, close, or acknowledge. So here is your state. This is the child class of the particular states. So you see you have your open, close, acknowledge, and change state. I am looking at the implementation and it is just default. You are not missing anything by not looking at it. And then you have your TCP connection that has a pointer to the base class and it's calling it as current. So what is the current state, right? In the constructor, we are setting the current to closed because that's our starting state, right? So it is pointing to a TCP closed. Why the instance? For that you go back to singleton. It was through the instance that if it is not created, create. If it is created, just return the pointer to the created instance. So you are always only using one. Okay? Then you have the get state. It just returns the name of the current state using the type ID operator. So you see a lot of things that we have studied in the past. If the method open is called, right? What happened when the open was called? Established. If we were in established and open was called, then we went to listen. If we were in listen and open was called, no, I made a mistake. So if it was in closed and open was called, we went to listen. If we were in listen and open was called, it went to establish. So let's see what is happening here. It calls, uses the current to say open this. Now here, this is your polymorphic call. Because which open will be called will depend on where it is pointing. If this is the first time the open is called, then it is calling the open of the TCP closed. Okay? Same idea with close, acknowledge, calls the acknowledge. So basically all three of these are polymorphic calls. Depending on where current is pointing at this point is which method will be called. Then we need a change state, right? So the new state, what are we doing? We are just making current point to the new state, whatever new pointer is doing. So the open of all those will change the state. And here is your TCP closed. So we are looking at one of them and then you get the idea of the other. So here is your use of the singleton design pattern, right? TCP closed constructor basically is like an empty constructor, and you have your open method. The nodes you have to fix this part. So what basically your open or close or anything does is uses the base class to call the change state. Change state is only, sorry, not the base class, the change state is only with your connection object. So it uses that to change the state. Okay? So the TCP closed tells TCP connection to change the state to TCP listen. So it calls the method and says TCP open. Okay. If it was TCP listen, then TCP listen will call the change state of TCP connect to change it to TCP established, and so on and so forth. Same idea here, basically that you have your open, close, and you have your change doing the same thing, and the established. So look at it when you get a chance, but basically you understand one, you understand them all. There is not much to go over. So here you are testing it, you are saying input your action, open, close, or acknowledge. So you are, typically you would have done it through an if-else statement. So if you said C, if you want close, then C, open, O, acknowledge A. So C, it says current state class TCP closed, input your action again. So input your action is like your request coming for the connection. So if you say O, it's saying call TCP closed open, because the current state was TCP closed, the option chosen is O, so it calls open, and what happens? Now the current state class has become listen. Again, listen, open, it became established, and then the calls to close. And then the acknowledge basically shows you the current state class and asks for your. So instead of getting the input from an actual request from a connection object. In this case, we are just asking user to be the connection object and say, what do you want? What kind of request you are sending to me? Okay? Okay, I will kind of skip this one. That's an easier one, and I will probably, it would be easy for you to look through it. And any questions on this thing before we move on anywhere else? So from point of your last 20 points of your final, okay, the question I would ask you is more on your understanding of these, okay? I don't expect you to become experts on this in 2 weeks. I'm far from an expert myself. It's starting to get the idea. So this is what I would suggest. Read and then try to explain to your friend what each design pattern is and where it is used. So try to get that understanding from these slides. Don't try to memorize it. It will be of no help or very little help if there is some credit to it. But try to understand where are these used, and that's why the one thing that I tried the hardest in putting these slides together when I did was to keep the examples simple rather than taking some very involved example, so that you can get the idea as to where it makes sense. Okay, so study them, think in your own mind or tell a friend whatever makes sense, what it is in your own simple words without looking at the slide right after you have read, and think of where you would use it. If you can do that, you will be fine on the quiz. Okay? Your assignment 4 is meant to help you. In assignment 4, I'm just asking you to do 1 or 2, right? As an example. So there I've asked you to go a little bit further and try to code it out, right? In your final, I'm not going to ask you code. Okay? But you will be able to do well once you understand. So best way to understand is after reading, going through these slideshows, is to go back and think of an example where you will use it. Think of everyday examples, just as I have been talking about. You don't need a fancy example. You don't need a fancy simulation. You just think of everyday things and see. I mean, even if it has nothing to do with computing, right? We are always developing software for real things in the world. We don't come out with an imaginary thing and try developing software, right? Whether it was socket connections before we made telephone connections, and so many things, right? Our roots are in the reality. So even if it is not, it's the easiest thing to do is maybe you are developing an application to do exactly that. It could be something as mundane as creating a greeting card that we talked about, or something as fancy as embellishing a sports car, whatever catches your fancy. Okay? But think about these things. And there is no reason that you should not get a 20 on 20 on your design pattern quiz. Those are solid 20 points that can be just added to the chunk of your final score. Okay? So go through these. So there are 4 PowerPoints, right? You have the behavioral, the creational, the structure, and you had one that I had done before the final, the kind of the introduction one, right? What do I want you to know from those is the solid. Okay, again, know what those principles are. Understand them in very easy terms. Don't sit and memorize, will not help. And what are the undesirable properties of software? There was rigidity, there was fragility, those ones. Okay, so those are the things you want from that. one, and then these design patterns I think I have kind of told you. Okay, it's a simple quiz exactly on what I said. You will find questions. If you can do that, you will be just fine on the quiz. There is nothing else that will be asked on the quiz. I mean, at least I can't think of asking anything other than these things on design patterns. I will not ask you to code design patterns. Okay? So don't worry about classes and this and that. Know basically what it can be done and an example in your mind where what would be a good place where it would be used. Okay? Okay, so that way design patterns is done, kind of summing up the whole semester, right? We started right from the very basic, like a 101 variables, functions. I mean, when you think of it at this point in time, you say, really, did we start there? It seems like an era back. And then moved on to the heart and soul, which I always said was inheritance and polymorphism, right? So, but again, without having understanding of variables and functions, you cannot learn classes, and without knowing classes, you can't create family of classes, right? And then through these, we kind of tried to learn the techniques of dynamic memory, allocation, deallocation. Through the STL assignment, my goal is always to give you a feel of, how it feels when you are not writing all the code. And that's what you will definitely get in the next programming course, whatever you end up taking. Because nowhere will you really code the whole thing all on yourself. We just do it till 400 because we are learning, how to write code, kind of, so to say. And then moving on, we tried to bring in this more sophisticated concept of design patterns and see how design pattern I see as in twofold manner. One is how we use, now inheritance becomes a tool, right? When we learned inheritance and polymorphism, we say how do we create hierarchies, what is polymorphism, but here in design patterns, we see a use of them. They now have become tools, right? And it is a little more abstract, so to say. We are not talking about, we are looking at a template kind of a code, right? So again, I enjoyed spending this time with you throughout the semester. Hopefully you did too, and you, as much as you must have cursed me, and I have very thick skin over many years of teaching. I hope that in a month or two, once you are better rested, you find value in the hard work you put in this semester. There is no doubt hard work has to go in the course. I wish I could make that part simpler. But if it helps at the end of the day, it's all worth it, is what I believe. Right? So do a good job on this. After this, I am putting the ball in your court. Now you tell me what you need me to go over. Today was sent out, the W table code is out.
Yes.
Right? So do you want to look through it together? Or do you have, again, all that we are going to do now is optional. You want to stay, you don't want to stay, class is over. There is nothing in form of, but if you need me to go over anything, talk about anything, I am available here till you need me to. Any group of students want to look through the dummy table code together? Yes. Yes.